Hi students, welcome to the channel. So here in this video I'm going to talk about what is the difference between the translational motion and the rotational motion. Like there are the different terms we use usually for different kind of motion. Like you must have heard about the rectilinear motion or the 1D motion, 2D motion, curvilinear motion, and then there is simple harmonic motion. Then there is oscillatory motion and the periodic motion. Like this there are many terms that we use, and the two important terms are the translational motion and the rotational motion that we use for a rigid body which is performing the motion because of the external forces. So in this video we are going to just learn what is the difference between them. If you want to learn what is the simple harmonic motion and the oscillatory motion or the periodic motion, you can check other video that is available in the comment section. So here the translational motion and the rotational motion are the motion of a body because of the external forces. We are applying some external force and that body is performing that motion, or maybe that has some velocity, that has some energy, because of that it is performing that motion. Like here you can see on the screen that I have given the two diagram for the translational motion and the rotational motion. So like simple to analyze through this diagram, we can analyze it easily. So here I have taken a random shape rigid body, and then it is performing the translation motion. As you can see here, right, it is going from here to here. It is performing some kind of motion. We don't know whether it is a translation or the rotational. Then how do we define this motion? Is like that: if each particle of the body, like if you take the topmost particle of the body or the lowermost particle or any particle on the rigid body, that is forming some path like that, right, that is going on a path, then any other point on the same body will also move on the similar path, right? So this particle, if I have just taken two particles here, this particle is moving like this, so the lowermost particle will also move like that, right, on a similar path in a similar fashion, right, exactly same way. So at any moment, if I take the path of each particle of rigid body will be same. Like if we want to consider the example, then we can consider, let's suppose there is a truck which is going on, which is just moving. So then the complete motion of the truck, we can consider it as the translation motion, except the motion of the some parts of the truck, right? Now next, what is that? If each particle of the rigid body is moving in a similar path with similar velocity or acceleration, or the displacement of each particle of body is same, so then can we replace this rigid body with a point? Yes, we can replace this body with a point. So there will not be any difference between the motion of a particle and motion of a rigid body if it is just performing the translational motion. That's why we can replace it, and that point of replacement will be the center of mass, right? So if you don't know what is the center of mass, you can check my video on the center of mass. So we can replace rigid body with point mass. That is our translational motion. What about the rotational motion? In case of rotational motion, here I am talking about the pure rotational motion, because the term pure rotational and the rotational are the same. Many times you will just get the rotational motion term, which is similar as the pure rotational motion. What is the meaning of that? Is that you have a fixed axis with respect to you. Let's suppose you are sitting here and looking at this rigid body. So now this rigid body has a axis or a point about which it is rotating. It is performing, its particles are performing the circular motion. They are moving in a circular path. Axis means a line. Like for example, if I take a door, so then door side that is connected to the wall, that will be the axis of rotation of the door when we open or close it, right? Okay. But look here, I have used this term circular path. But the particle, if you take different particle, they will be moving on a different radius circle. Like if you can look here, if I take midpoint, so this is the radius. Okay, if I take the extreme point of this rigid body, so then this will be the radius, isn't it? So this radius will be different for different particles, right? Maybe same for some particles, but if I take all of the particles, it will be different for the rigid body. So what is happening is basically I can say that rotational motion is just the combination of the circular motions, right? These circular motions of course are of same or are of different radius. Okay, now I have said that, and then if I say that each particle is moving in a circle of a different radius, isn't it? The velocity of each particle or different particles, will it be different or not? Because we know the relation from the circular motion. What is that? V equals to omega r. The velocity of any point, linear velocity of any point or linear speed of any point from the axis of rotation, which is situated, the particle which is situated at a r distance, and that particle is rotating with a omega angular velocity, then the relation between the angular velocity and the linear velocity says that V equals to omega r. Okay, so now having said that, we know that r for different particles of the rigid body will be different, right? So r is different, then of course the speed will be different, right? So that's why different particles will have different speed, or you can also say the velocity. If velocity and the speed is different, isn't it, the displacement will also be different and the distance will also be different. All right. Now, can I replace this rigid body with a point mass? No, of course I cannot replace this rigid body with a point mass. For the concept of the velocity, distance and the displacement, different point will of course have the different distance, different displacement, different speed and the velocity. Okay, then if I take this axis should be fixed, axis of rotation should be fixed. What are the practical example? Like for example, if you are just sitting and if you just turn on the fan, so then that fan is rotating about its axis. Fan particles are rotating or fan wings are rotating, right? So these fan wings are performing the circular motion or the rotational motion. That is the example of the rotational motion. I hope you must have understood what is the difference between the translational motion and the rotational motion. If you want to learn more about the rotational motion, you can check other videos available on my channel. And if you like my content, then you can subscribe and you can share to your friends as well. Thank you very much.